Hi everyone. Today's tutorial will be about stack. I'm talking here stack in terms of computer science stack. So I'm going to talk briefly about stack, and then we'll be talking about implementation and where we'll be using stack. And hopefully that will be on the second tutorial. So the first tutorial about stack, I'll be just giving you some example, and hopefully you'll be able to understand what we mean before we move on into the implementation. Now, stack is a collection of elements, and the two fundamental operations on the stack are push and pop, which I'm going to explain that to you in a minute with an example. So what that means, it means that you remove the most recent added element from the actual queue or collection. Okay, so just like we look in here, so we have the push when we push data element into the stack. And then when we say pop when we start taking the data or the element out of the stack. Now, we also refer to it sometimes as last in. So the last in, first out. So stack main operation. Stack is an abstract data type that holds order, linear sequence of item, in contrast to a queue. So a stack is a last in, as I mentioned earlier, first out. So sometimes we refer to it as LIFO, as in last in, first out. And that's also, if you say that with yourself, it kind of helps you remember when you hear stack again in the future. Last in, first out structure. In a minute, as I said, stack is abstract data type. Abstract, which I'll explain that to you in a minute as well, just to give you a better understanding. Just briefly, I'm going to go over abstraction. So a real life example is a stack of plate. So let's say we have plates in the kitchen, which is stack of plates, let's say 10 plates in the kitchen. So you can only take the plate from the top of the stack. You can only add plate to the top of the stack. But if you want to reach for the plates at the bottom, so you have to keep removing the ones at the top. And those ones are the last you put in. And that's basically stack. So the stack main operations are push. That's when we push the data or the elements into the stack. Pop is basically to remove the element from the top of the stack. Like I said, top of the stack. So last in, first out. Peek returns a copy of the element on the top of the stack without removing it. Also we have is empty, check whether a stack is empty. So basically this function just checks if the stack is empty or not. And if the stack is full, then we say is full, check whether the stack is at maximum capacity, then you are enabled to add more into it. So let's have a look at this example. So we have here, we push. So we always refer to it as, so let's say this is the stack, and this, let's say this is an empty stack. So when we push, so the first one goes to the bottom, second one, third, fourth, fifth, and then when we start one, if I want to like start popping out the element or data, then I would remove first the last one here. So before I move on into details with examples, let's try to understand, because I mentioned here stack is abstract data type. So what is abstract? Abstraction means removing unnecessary details. So abstraction, basically, to simplify things, that are very complex. So we are humans, we always use abstraction. So let's have a look at this example. So when I want to draw a cat, so that basically it's a drawing of a cat. So this is abstraction of a cat. Let's have a look at this example, which is quite a good example. So here, as you can see, the heart here on the left, that is too realistic. By the way, this is still abstraction. Now, this is the just right abstraction to it. And then here to the right, as you can see, this is just a bit complex in terms of abstraction. Let's have a look at this London Underground abstraction, the trains. As you can see here, the tube map on the right, that's what, if you go and visit any of these stations, you will see this tube map on display or on the board. So as you can see, this is abstraction version, but the actual one is actually would look like that. The reason why we use abstraction of it in terms of the representation of the map is to make our life much easier. So as you can see, the different here. Okay. So if you look here at St. Paul's and Bank Station, just around here on the central line, as you can see here, which kind of the abstraction of it, you can see the bank, St. Paul's, as you can, like the kind of, they made a bit of distance to make it readable and sort of easy for you to understand. While if you have this in the real life, that was very confusing. But the actual central line would go in central London, would basically travel that way in terms of their tracks. Here we go, another example. So many real-world objects and situations are represented in computer systems. So let's have a look at the flight simulator. Different planes will be represented in some way within the system. So if object-oriented programming is used, the plane will be an object with sets of properties that are relevant to the features of the simulator. So what that means, some details are essential to the actual simulator, while others are kind of not really important, such as the seat. So that would be, you can be used an abstraction, or kind of, we just use a sort of representation briefly to it to make it kind of relevant to the actual simulator, but not in actual terms of the features and functionality. So let's have a look now in terms of abstraction. Now in terms of stack, we understand what abstraction is. Just remember, for me to just a cat. So how would you want to draw a cat? You would draw it that way, maybe with a bit of whiskers. Then that is abstraction of actual cat or real life cat. So let's have a look at this example of a stack. So let's push Ben into this empty stack. So you can see Ben here at the top. Then we'll push Django to the stack. So Django will go on the top of Ben in terms of the stack, and Django will be at the top. So last in, first out. So in this situation, we are just pushing. So we use push. Here, we push Anna to the top of the stack. And then we said, let's pop. As soon as I say pop, then which one do you think would go first? So if I have Anna at the top, and then I want to pop from the stack, then last in, first out. So in this situation, Anna will go out of the stack, and then we'll just have Django in the list, and then Ben. So if I want to reach to Ben, then I'll have to pop Django. Okay, and then, so remember, I had push Anna, and then I pop. So I would pop whatever at the top of the stack. That will be Anna. So here I just have Django and Ben. And then I decided to push Zoe. So if I push Zoe, then Zoe will be at the top of the stack. Yeah. And then Django and Ben. As you can see, in terms of the operation, we'll go from top to bottom. And this is a stack.